according to their research findings, toilet door handles in shopping centres are the most inhabitable places for bacteria. The door handles contain 7.66 million bacterial counts, while the dirty dollar bills only contains around 30,000, which is about 255 times more in amount of bacteria than on the dirty dollar bills. The health authorities have also advised that humidity on our hands after we washed our hands with water would actually provide the bacteria with nutrients to grow and spread, causing more cross-infection rather than eliminating the infection. And though not all the bacteria causes illness, but certain types such as E. coli, Salmonella, and Staphylococcus aureus can cause illness, particularly in children and in the elderly. Now here we have a table of the top 9 black hidden danger spots in the shopping centres. So you might want to actually have a look at this so you know how much bacteria actually we live in an environment with. Now, as I was saying before, that the toilet door handles contain roughly 7.6 million bacterial counts, and a dirty dollar bill only contains around 30,000. Apart from food trays, which has 7,400, food manuals, ATM machines and lift buttons are coming up on the 4th and 5th place and 6th place on the table with around 963 bacterial counts. And also supermarket trolleys, shopping centre entrance door handles and elevator handrail also contain bacteria as well. And these sources actually from that laboratory which is hired by the wet tissue manufacturer. So, what can we do to reduce the amount of bacteria? This is where ShieldGuard comes in. So, what is ShieldGuard, you might ask? ShieldGuard is a coating produced by a patent process which utilizes the high velocity melting alloy that we use, which bombards with the metal surface. And the end product contains qualities of hardness, easy to clean, high bonding, and it actually resists very high temperature. Additionally to the ShieldGuard coating, this coating can be applied with oxidized silver. It actually produces the antimicrobial effect. So how does the antimicrobial ShieldGuard work, you might ask? Through the high velocity melting process, we use silver metal which is melted into the ShieldGuard coating where the particles are interlocked together, so it binds in with a lot of pressure and heat. And the end product, and the silver ion is produced in the process, which is the end product that we're looking for, allowing the finishing product to have the antimicrobial effect. This effect I've just explained in the silver ionized theory and how silver ion is used. Now this effect is caused by silver, as I'll repeat again, this effect is caused by silver ion's positive binding to the bacteria's negative charge, resulting in the bacteria to cease function and self-destruct. Here we have a magnification on the surface of our ShieldGuard material binding in with the metal. As you can see, this is the stainless steel layering, and this is only at 500 magnification. Okay? And the layering itself, this is ShieldGuard coating with the antimicrobial, and these white dots here are the actual silver particles. What happens is when bacteria, when it binds onto the surface of any ShieldGuard surface, when it comes in contact, the silver particles would be released from the ShieldGuard and actually interact by ionic charge. So every time a bacteria with a negative charge comes along, the silver particles would attach to it and it will actually resurface and it will actually go back into the layering after it kills the bacteria. So this would give it a long-lasting effect. And here we have the actual test results from labs showing that when we were trying to test for reduction of the bacteria itself. What we did here was actually planted bacteria on the agar plate and then placed the silver ions on the agar plate and tested it for 24 hours to see how long and how quick it actually kills all the bacteria. And as you can see here, it started off at 100% at 0 hours. When it first planted, there's still 100% of the bacteria on it. And as time progressed through, within hours, it would reduce more than 80%, as there's only 20% left of the bacteria. And within 24 hours, the reduction rate is actually more than 99.99%. So therefore, your product, or the metal surface itself, has no bacteria on it. And these are the test details which we actually use in the specifications we used. And our results show that the rate of bacteria juice is similar in all test replicates. So we tested it numerous of times and all our results came back to be similar in results. And identical tests were actually done by two different companies or two different specifications. Two different companies using the same specification of the JIS 2801 year 2000. And we tested using another detection center, which is in Guangdong, of microbiology. We did the same test, but they used a different specification of JCT 897 year 2002. And yet the results were the same as the SGS and TUV. So you might ask, how does our ShieldGuard layer performance compare on different bacteria? Because there's quite a few, 650 types. Here's the 5 main types that we use our ShieldGuard layer on. We use it on Escherichia coli, Staphylococcus aureus, Pseudomonas aeruginosa, Klebsiella pseudomonae, and Salmonella atrachic. And as you can see here, all 5 of them, within 24 hours, the percentage reduction is larger than 99.9%. So most of the bacteria that is on the layer of the metal surface is actually eliminated. And this is done by showing you we only use 5% of our silver concentration, as this can differ with our products and the customer's need. So before I continue, I know you might be thinking like, oh, this is nanotechnology, right? But I can tell you that this is rather different. And here's a comparison between our ShieldGuard layer compared to the nanotechnology. Now the silver ion size that we have here is actually only 0.03 millimeters compared to nanotechnology, where it's much smaller. It's 1 × 10 to -9 millimeters. And our antimicrobial effect, because due to the theory behind the silver ion, is actually continuous and longer lasting. But because nanotechnology, once it's used up, it doesn't get released back out, so it's only instant but short term. You can actually see both our reduction rate are pretty similar, larger than 99.98%. But the main difference is with the manufacturing time, because our product, we use physical changes rather than chemical changes. Our production time's a lot shorter. I'm pretty sure quite a few of you have seen the demo that we put on before we started this talk. Whereas the nanotechnology may be rather longer because it uses a chemical reaction. It normally takes a lot of time to extract these silver ions. With the durability of ShieldGuard, because it's embedded into the layer itself, it is longer lasting, and it actually has a longer toughness to it because it resurfaces when the bacteria comes into contact, and it embeds itself back into the layer when the bacteria is not there. Nanotechnology is normally spread out on an even surface, so once it's used up, then it's gone. So the durability is a lot lower than our ShieldGuard coating. And with our application usage, we have a very wide area because we can actually apply it on any metal surface, whereas nanotechnology may only be applied to some metal surface or maybe some other materials. Now let us look at some of the applications we can apply ShieldGuard antimicrobial technology